Hello and welcome to Young Minds versus Physics. Yes, in this video we are going to discuss about electric field due to electric dipole, and also we will move on to the electric field due to uniform charge distribution. Right? It's a continuous charge distribution we are going to discuss about. Right. So now coming to electric dipole, as we have already discussed, right? Electric dipole is that which has two dissimilar charges of same magnitude separated by a constant fixed distance. Okay, so that is called a dipole. So here you can see a dipole like with the plus q and minus q being the two charges separated by a distance 2L. 2L we take it for our convenience, right? When we derive things, right? Always we talk about distance of a particular point in the electric field due to a dipole. Suppose if I say that there is an electric field created around the dipole, right? So now if I want the electric field strength at this point, right? So always the distance is measured from center of the dipole. Always the distance is measured from center of the dipole. So that this center will be at a distance of L from one charge and L from the other charge. Thus we take 2L here for our convenience. Okay, so what is the important point that you have to keep in mind? That always whenever you discuss about the electric field due to a dipole, always the distance of the point from the dipole is measured from the center of the dipole, that is from the midpoint of the line joining the two dissimilar charges of the dipole, right? So now the important physical quantity about which we are going to discuss or include in this discussion is dipole moment. Dipole moment, which is P bar, which is a vector quantity, and its direction is always from negative to positive charge. It is always from negative to positive charge and along the line joining the two charges. This is how the dipole moment will be, and the magnitude of it is given by length of the dipole multiplied by the charge. Length of the dipole multiplied by the charge. Charge of a dipole means either of the charge magnitudes we are going to take, because both the charges have same magnitude, right? So this is what the dipole moment is. Coulomb meter. Coulomb meter is the unit. Of course, that everyone, you all know that. Now suppose if you take an example, three charges plus q and minus 2q are placed at the vertices of an equilateral triangle. What is the dipole moment of the system? Right here, this is how it is given. There are three charges. Okay, now how are the charges here? Like minus 2q, plus q and plus q, right? So now this is how the system is given. Now here he is asking us to find out the dipole moment. Now while we are talking about dipole moment, we said there are two charges separated by a fixed distance, is it not? Right? So that is how we defined dipole. But here what we see here is three charges are there. Right. So that means we need to convert the system into the system in where we can see the dipoles. That means this system has to be converted like this. See here, minus 2q is split into minus q. And this minus q is now at a fixed distance d from plus q. This minus q is also at a distance of d from plus q. Because this is an equilateral triangle, the system is given like this. So what you observe here is one dipole from negative to positive charge, dipole moment P bar. And now this is also P2 bar, P1 bar, P2 bar. Now if you observe, Q and Q, Q and Q. That means magnitude of these two dipoles is same. Dipole moments is same. And now this is a part of an equilateral triangle. So therefore angle between these two dipole moments is 60 degrees. Beautiful, isn't it? So that what did we do? The system is given like this, as like 3 charged system. We have split into 2 dipoles system, right? We have converted the whole thing into 2 dipoles system. Is it not beautiful? Yes, very interesting also. So you have 2 dipole moments. That means 2 vectors acting at an angle of 60 degrees between them. Then the resultant acts in this direction, right? So bisecting the angle between the two. How does it act, bisecting the angle between the two? Because magnitudes are equal here. P1 is equal to P2. That is modulus of P1 bar is equal to P2 bar. So what is the net resultant, or the resultant is when 2 vectors are of equal magnitude, then the resultant is given by 2p cos theta by 2. So that is what here we are finding. P net is equal to 2p cos theta by 2. Theta is 60 degrees, 60 by 2 is 30 degrees. 2p cos 30. So 2p root 3 by 2. So that is root 3p. What is p? P is charge multiplied by the length of the dipole. Here the length of the dipole is the length of the side, right? That is d. So therefore this is the resultant magnitude. This is the resultant magnitude, and you know that how the direction is, that it bisects the angle between the 2 dipoles and acts vertically. Like suppose if you take it as x and y axis, then it is along the negative y axis or downwards. Clear? Right. So this is very, very important concept where you can split or you can convert the system into dipoles. Then you can solve the problem so easily and so directly. Okay. So please note it down. Now going with the general concepts of dipole. So these kind of things or questions can be asked also in the board exams, right? So that is the electric field at a point on axial line of a dipole and electric field at a point on the equatorial line of the dipole. These two are the most important concepts where you can expect any one of them to be as one of the important questions for your boards. Okay, but here the concept is important for us. Right? We are aiming to understand the concept and apply it. Right? So now let us see like how to solve this one. So you have a dipole and the dipole of plus q minus q separated by a distance of 2l, or that is length of the dipole is 2l. And let us take capital P to be the dipole moment, where dipole moment is given by 2l into q. Right? So these are the things that are given to us if you assume. Now let us find out electric field strength at a point, right? Electric field strength at a point in the field on the axial line of the dipole. Axial line means an imaginary line which passes through along the line joining the 2 charges or along the length of the dipole. Right, through the 2 charges. So this is the axial line. Okay. So now let us imagine that small p is the point where I wanted to find out electric field strength, and daring minds, you know what to imagine here. Yes, unit positive charge has to be imagined here in order to find out the electric field. So now when you imagine a unit positive charge, because of this negative charge, there is a force of attraction in this direction, even in the negative x-axis direction or towards the dipole. If you take dipole as a reference, right, towards the dipole. And now the force on this, because of this positive charge of the dipole, or the electric field it will be away from the dipole because of this positive charge. So you have two forces, F1 and F2, or F minus and F plus, acting on positive charge. So therefore I can say that it has E minus and E plus. Right? So in terms of electric field strength, I can write it as E minus and E plus. Now if you say that, where is this point P located? This point P is assumed to be at a distance of R from the dipole. What is the meaning of from the dipole? It means that from the center of the dipole. So from the center of the dipole, at a distance of R we are taking, and 2L is the length of the dipole, and from the diagram it is very clear that this distance is total R minus L, because this is L and this is L, and that is why for this convenience only we always imagine the length of the dipole to be 2L. So this whole distance is R minus L is this. Now from here to here it is R, and if I want this one I am going to add L to this. Therefore R plus L from plus Q charge, R minus L from minus Q charge are the distances, right? Respectively. Right. Now if I say that what is the electric field strength due to negative charge? That is 1 by 4 pi epsilon naught Q by, what is the distance here? R minus L. Distance between the negative charge and the point is R minus L whole square. And what is the direction? It is towards the dipole. It is towards the dipole, or rather you can say in this context towards negative x-axis. Now E plus, that is the electric field strength due to positive charge, 1 by 4 pi epsilon naught Q by, what is the distance now here? Yes, it is R plus L. So R plus L whole square. And how is the direction? The direction is repulsive. Therefore, the force is repulsive. Therefore, the direction is away from the dipole. It is away from the dipole. Now, you know the net is, because here what is the angle? Angle is 180 degrees. If you go by vectors also, cos 180 is minus 1. Therefore, you will get A minus B whole square under root, right? So therefore now here the difference will be the net. So the difference here, which will be maximum? See, this negative charge is very close to the point. So therefore the pull because of this negative charge is high. That means the intensity of the electric field because of this charge is greater than intensity of the electric field because of this charge, as this charge is far from this one. Right, so therefore E minus is greater than E plus. Therefore E net is equal to E minus E plus. So therefore now finding the difference, substituting, and then you can take the LCM, you will be getting A plus B whole square minus A minus B whole square is 4AB. So thus you will be getting, and here A minus B whole square into A plus B whole square is A square minus B square whole square. Right, and further simplification you can see that the net electric field strength on the axial line is like Q by 4 pi epsilon naught 4 LR by R square minus L square whole square. This 4 LR I am splitting it into 2L into Q. 2L into Q will become P. So P into 2R remaining 2R. So P by 4 pi epsilon naught into 2R by L square minus R square minus L square. R square minus L square. This is E on axial line. This is E on axial line. Suppose if the given dipole is very small. That means length of the dipole when compared to the distance of the point from the dipole is very small, or rather R square is far greater than L square. Then L square can be neglected in this. When you neglect L square here, R square whole square is R power 4. This R and R power 4, 1 R will get cancelled. You are left with the R cube in the denominator. That is what we are writing it here. 2P by 4 pi epsilon naught into R cube. So this is the electric field strength on the axial line of a short dipole. When it is specified as a short dipole, this is what you have to take. Or for convenience, you can write it as like 1 by 4 pi epsilon naught, always, because this is how we write it, 2p by r cube. Like this is the easiest way of, like, because this is always a constant. it will appear everywhere. So therefore there is no need for you to remember this. That what it is 2p by r cube, or rather if it is a longer dipole, then it will be 2r by r square minus l square whole square, right? So this is the dipole on the axial, so this is the electric field strength due to dipole on its axial line at a particular point at a distance of r from center of the dipole, right? So that is what which you have to remember, right? Please note it down, pause the video in between and you can note it down. Now the next, immediately we will be moving to equatorial line. Whenever we discuss about axial line, either it is in magnetism, is not, even in case of a magnet is of course, even it is a dipole. Is it not a bare magnet? It is a dipole. You have poles, small m and small m, that is with the north pole and south pole, dissimilar poles separated by a constant fixed distance 2l, where 2l is the length of the magnet, right? So there also you will be discussing axial line and immediately equatorial line. Here also we are doing the same. Equatorial line. What is equatorial line? The line which passes, an imaginary line which passes through the center of the dipole perpendicular to its length. How is it? Perpendicular to its length. As though that imaginary line bisects the dipole, right? So that means it divides into equal halves. So therefore now this is the center, and through the center we are imagining a line, and now our concept here is that we have to find the electric field strength due to this dipole at this point. So I have to imagine a unit positive charge here as usual. Therefore you will be having, because of this positive charge there is a repulsion in this direction, because of this negative charge there is an attraction in this direction, right? So this is on equatorial line. What does it mean? It means that this is at equal distance between these two, from these two, right? It is at equal distance from these two charges. It is not at any random point. It is at a point on the line which is bisecting the dipole. That means this will make same angle as that of this one. That means the electric field strength, the direction makes an angle theta with positive charge, and here you can see that this line also makes an angle theta here. So now if I say that these two are theta, that means inside the triangle the two interior angles are theta. Now the opposite exterior angle is 2 theta. Obviously the angle between E1 bar and E2 bar is 2 theta. And you can observe that if this is 2L and this is the R, what is R? Distance of the point from center of the dipole. If this is R from Pythagoras theorem, and that's the best theorem that is there in our hand to solve so many problems, right? And this will be so this is L square plus R square, and this is L square plus R square here, and here also this is L square plus R square being the length, right? So and now you can see that 1 by 4 pi epsilon not into 1 into Q, because E1 is equal to Q by R square, that is L square plus R square under root whole square, right? So that is L square plus R square under root whole square is the distance square, right? Let us write the same thing now, but here what is important? Again, there are two vectors of equal magnitude, then the resultant is absolutely right. 2e cos theta by 2. Here in place of theta you have 2 theta. So therefore the resultant or the E net is equal to 2e cos 2 theta by 2. This is the easiest way. Fatafat you can finish the problem, right? So this is applying vectors wherever it is essential. So when you apply those concepts, what you have learned from vectors, right, then your job will be very easy. So therefore it is E cos 2 theta by 2 is E 2E cos theta. Now our job is to find out, because we know E, is it not? It is 1 by 4 pi epsilon naught into q by L square plus R square under root whole square, square and root will get cancelled. So therefore we know E. Now the point here is to find out cos theta. Now let us see what is cos theta from this triangle. So from this triangle, what is cos theta is equal to? Cos theta is equal to adjacent side by hypotenuse. So therefore L by root of L square plus R square. Yes, L by root of L square plus R square. Substituting that, you can see that it is 2q into L, 2q into 2q into 2L, q into 2L. That is dipole moment. 1 by 4 pi epsilon naught. Now you see a square plus R square into L square plus R square into L square plus R square whole power 1 by 2. It will be simplified to L square plus R square whole power 3 by 2. So this is the dipole moment. This is the electric field strength on equatorial line. Right, on the equatorial line of a dipole, where capital P here is dipole moment 2L into Q, 2L into Q. Right? Yeah, please note it down. This is a very shortcut and it doesn't take even 1 minute of time for you to solve. Since you know what is E, you can directly look into the diagram, can say what is cos theta and directly you can say the answer. So no need to mug up any kind of the derivation, because in certain books, in certain board books, very lengthy concept is given to you. Here that is not at all necessary. It is only a two-step problem. It is only a two-step. One step and final substitution. This is the second step. Right? Very, very beautiful and interesting concept. Dear students, I recommend everyone to copy this one so that it will help you in solving the problems very quickly and very smartly. Right, now coming to small dipole. Yes, you know that L square is far less than R square because the length of the dipole is small. So substituting that, you will be getting, like in this equation, you are going to substitute. You are going to neglect R square. So L square 3 by 2, whole power 3 by 2, 2 will get cancelled, L cube. L square is neglected, R square 3 by 2. So R cube is left here. So therefore it is 1 by 4 pi epsilon naught P by R cube. But what did we get in axial line? We got it to be 2P by R cube. 2P by R cube. So therefore you can say that E axial line is equal to 2 times of E on equatorial line in case of a small dipole. So whenever a small dipole is given, or in the problems if it is mentioned it is a short dipole, small, usually this is the word used, short dipole is given to you. That means always there is a relationship between the electric field strength on axial line to the electric field strength on equatorial line. That is, E axial is equal to twice the electric field strength on equatorial line, and this is only in case of, yes, short dipole. Right, make a note. Now the most important concept. E at any random point due to a dipole. In the previous two cases, we have seen that we are limiting ourselves. We are limiting ourselves saying that the point is on axial line or the point is on equatorial line. That means it is only like when the points are given only on those specific axes, then only you will be like able to solve that. But now here it is a general point. And but the dipole what you are taking here is a short dipole, right? In case of a short dipole, at any point if the electric field strength has to be determined, this is the best method of solving it. Right, now let us suppose that this is the dipole plus q minus q, 2L being the length of the dipole. Now from the center of the dipole, at a distance of r, right, there is a point P, and at this point you are imagining an unit positive charge. Then only you will be able to like come to a conclusion for applying like what do we call Coulomb's inverse square law we are applying, and then finally finding electric field strength, right? So therefore here, now when I speak about this one, this point here, right, and here at the center of the dipole, now you have, let me take this to be, plus q minus q. Let me take this as minus p minus q plus q. Okay, right. So the dipole here, the dipole moment, whatever is there, it is resolved into two components. One is p, one cos theta. So at this point, it is even here, right? And then the other one is E2 opposite to this P2, right? And the effect of the resultant is E here. So you have E1. What is E1? 1 by 4 pi epsilon naught. And the into, right? So now when you talk about this P, right? This P is on axial line, is it not? This P is on axial line, like as you take, like thus, therefore it is 2P by R cube, is it not, for short? But now which P you have to take? The component in this direction, which is P cos theta. So 2P cos theta by R cube, right? So now you are taking one of the component, right? That is 2P cos theta by R cube. And now when you talk about the one which is absolutely perpendicular to this one, see, if you talk about the dipole in this direction, we are taking the dipole in absolutely perpendicular direction. But that means what is the line which is perpendicular to axial line? It is equatorial line. Yes. So that means if you are taking P cos theta along axial line, then automatically the other one will be in equatorial line. Is it not? So therefore you are using the concept of equatorial line. So 1 by 4 pi epsilon naught P by R cube, where axial line it is 2P by R cube. Equatorial line it is P by R cube. But what is the dipole moment in the direction perpendicular to P cos theta? It is P sin theta. Fine. Therefore in place of P, you are taking P sin theta, right? Here you are taking in place of P cos theta, but here this is along axial line and this is along equatorial line. So what is it? So therefore it is 2P by R cube as per axial line concept and P by R cube as per equatorial line concept. Is that clear? Right. So therefore two electric field strengths are acting here in two mutually perpendicular directions. The resultant here is E net is equal to root of E1 square plus E2 square. That is right. So taking all the things whichever are constant, and you get 4 cos square theta plus sin square theta. So this can be converted into 1 minus cos square theta, thus 1 plus 3 cos square theta under root. So this is electric field strength at a point randomly, right? Where that the line joining the center and that point makes an angle theta with the dipole moment, right? Angle theta with the length of the dipole, you can say. Clear? Right. So this is how you can derive a very, very important concept and a beautiful concept. And if you wanted to find out alpha being the angle made by E bar with E1 bar, right? The tan alpha is equal to E2 by E1, right? So that is substituting like E2 by E1 in the sense, what is E2? 1 by 4 pi epsilon P sin theta by R cube. By E1 1 by 4 pi epsilon 2P cos theta by R cube. So everything will get cancelled. You are left with 2 tan theta by 2. So therefore tan alpha is equal to E2 by E1, which is equal to tan theta by 2. Just you substitute these values here. That's all. Right? Note it down. Now the second part of electric field strength is, already electric field we discussed that. Let us split it into two parts. So one part for like taking charges separately, right? So where you have taken one charge system, two charge system and multiple charge system, and then we discussed about the dipole where two charges are separated by a fixed constant distance. And now we are going to the second part of electric field where the charge is continuously distributed, right? So suppose there is a body where there is a charge of small dq or q1 q dq1, dq2 or something like that, right, where the position vectors are given r1 bar, r2 bar, r3 bar with respect to the point. Then the electric field strengths because of them will be dE1 bar, dE2 bar, dE3 bar. So then what is the net? Net is the vector sum of all these things. dE1 bar plus dE2 bar plus dE3 bar plus so on. So that means this vector sum, it is uniform distribution and a continuous distribution. For continuous, we will take the addition with integration. So therefore, E bar is equal to integral dE bar. So this is like in center of mass concepts also you'll be doing this, like continuous mass distribution. That continuous mass distribution may be uniform or non-uniform depending on whatever the condition is given. You will apply the limits and then you will determine the center of mass. Right? And here also the same case here. So it's a continuous charge distribution. As the starting of electrostatics only we said, like we compared with mass and charge. Charge is also such a quantity which is a scalar quantity, and everybody has a charge either positive, negative or zero. So therefore, and here we say that a uniform or a continuous distribution of the charge whenever it is there, how to determine electric field strength due to such bodies, right? A body with continuous charge distribution. Let us see one particular case in this video, right? That is field due to charge on a ring. So there is a circular ring of radius A, right? There is a circular ring of radius A. So now this circular ring, let us take that a small element of charge dq is at this point. And now the line joining this to the point where we wanted to find out electric field strength. Right? Let us suppose that this is a small point P. Right? And here you are imagining a unit positive charge as usual. Now, if this is at a distance of x from the center of the ring, always when such bodies are given, even in case of dipole, you have seen that the distance of the point of consideration must be from the center only. Here also we are taking the distance of this point where we wanted to find out the electric field strength is from center of the ring only. So the center of the ring, it is x, radius of the ring is a, and you can see that this is the hypotenuse here. So root of x square plus a square. Now, if this is the direction of the electric field strength, right, because of the positive element of the charge dq, right, positive charge, small element of positive charge dq, from here, this is the direction of electric field strength. And as the charge is dq, the electric field strength also we are taking very small element of electric field strength dE. And if we resolve it into components along x-axis, it is dEx and here it is dEy. And if alpha is the angle made by the point, the line joining the point and the small element of the charge with the line joining the center and the point is alpha, then you have this dEx is equal to dE cos alpha. Right, so therefore we are finding it out to be dEx is equal to dE cos alpha. But what is dE? Yes, everything is here. Everything is given. You know the charge, you know the distance, you know Coulomb's inverse square law. 1 by 4 pi epsilon naught dq by distance square. So root of x square plus a square whole square root and square will get cancelled, right? So you know dE. Now dEx is equal to dE cos alpha. So now what is cos alpha from the diagram again here? So what is cos alpha is equal to x by root of x square plus a square. It is looking as though it is similar to equatorial line of the dipole, is it not? Yes, yes, right. Now substituting cos alpha, then you got dEx is equal to this much. What is dEx? This is only a magnitude. Now I want to make it a vector quantity. What will I do? I have to only multiply the unit vector in that direction to the magnitude. What is the unit vector in the direction of x? Positive x. It is I cap. So thus, this is the dEx bar. So now along this line, right, it is dEx bar. Now integrating on both sides, you will get Ex is equal to 1 by 4 pi epsilon naught. If whenever I write I cap here, bar should be there. So therefore 1 by 4 pi epsilon naught Qx by x square plus a square whole power 3 by 2. Right? So this is what the electric field strength, right, at a particular point due to the ring. Right, now here the concept is, how does it vary? Right, what will be the minimum value of it? What will be the maximum value of it? Right, because you can see that x is there at both the places, in the numerator as well as in the denominator. So definitely there will be a change in Ex. Ex is not constant. So now from this formula you can very clearly say that yet x is equal to 0, Ex is 0. That means what is x? X is the distance from this point. It is 0 in the sense at the center of the circular ring. So at the center of the circular ring, electric field strength is 0. We can understand that one. Why? Because here it will have, suppose if you imagine a unit positive charge, from every direction you will have a repulsion. Right? So therefore the net will be 0. Right, and you know that E is equal to 0 at x is equal to 0 from this, and but already from theory we have learnt, like while defining electric field only we said, like electric field strength becomes 0 at infinity. That means the field lines of any charged body will extend till infinity. There the intensity becomes 0. That means definitely at x is equal to 0, E is equal to 0 is from the relationship whatever you got, and also from the theory what you have learnt, at larger distance also E is equal to 0. Therefore, x is equal to 0 and between x is equal to either plus infinity or minus infinity. Between these two limits, right? So that means it starts with 0 and again it becomes 0. That means between these two there will be some maximum. That means this is going to increase and again decrease and become 0. Clearly, is it not? Right. So therefore there should be a maximum for E. So E should have certain maximum value. So how to find out the maximum value? Like where it will be? So when you differentiate this one, the differential of that is equal to 0. That means at that particular x value where dEx by dx is equal to 0 gives you the location of maximum Ex. So now let us differentiate that equation. So you got the equation to be 1 by 4 pi epsilon naught qx by x square plus a square whole power 3 by 2. Differential of this is equal to 0 if you do, right, u by v method. Applying that and then simplifying, you will get x is equal to, at what value of x you are getting this to be maximum? Yet x is equal to plus or minus a by root 2. That means you have again at two values you are getting maximum. That is along positive x-axis, that is at plus a by root 2 you are getting maximum, and at minus a by root 2 you are getting a maximum. So now substituting a by root 2 in the formula already given, like for E or in the relationship of E, Qx, x is equal to a by root 2 by x square plus a square whole power 3 by 2. On simplification you will get E max is equal to 1 by 4 pi epsilon naught into 2q by 3 root 3 a square. Very, very, very important relationship. Right? This is for E max. That means where the electric field strength will be maximum in case of a ring with uniform charge distribution or a continuous charge distribution. Right? Clear? Note it down and let's see how graphically we can represent the change in E, right, with respect to the ring. Right, so on either side of the ring, positive x-axis and negative x-axis. At the center of the ring, E is 0. Taking E on y-axis and the distance on x-axis, if you can see that, E becomes 0 at the center of the ring. Right, at x is equal to a by root 2, it becomes maximum. Right, that is 1 by 4 by epsilon naught 2q by 3 root 3 a square. This is E max. That means electric field strength increases. It becomes maximum at a distance of x is equal to a by root 2. Where A is radius of the ring. Where A is the radius of the ring. That means within the ring only you will be getting the maximum E max. And then gradually it decreases. Right? And again it tends to 0 as x tends to infinity. So therefore I can write E tends to 0 as x tends to infinity. Right. So on the other side, on the negative side, if you see, E is again 0 at the center of this ring. And as you are moving on the other side of the ring, onto this side of the ring, right? So there at x is equal to minus a by root 2, you will get E maximum again here. And here you can say that E tends to 0 as x tends to minus infinity. Right? So this is how electric field strength will be changing about the ring with continuous charge distribution. Right? So this is all for this video, and if you have not yet subscribed, please subscribe